Hi, I'm Dan Wisey, the technical support guy at the Lessman Instrument Company in the Chicago metropolitan area. If you're watching this, you're probably in that group of people who have a process that isn't well tuned. You're not alone. Industry surveys show that about half of all control loops are not properly tuned. As you well know, a typical sign of an improperly tuned process is when the process variable, the value in the top display here, oscillates back and forth. It just jiggles around. So we can see here it's going below 200, above 200, below 200, above 200. The good news is that Honeywell's auto-tuning algorithm called Accutune can tune probably about 2/3 of the loops out there. Accutune excels at tuning temperature control or thermal loops. The purpose of tuning is to match the controller's response to the actual process operational conditions. What Accutune does is it alters the controller's output, watches the response, and then calculates the three tuning constants, which are proportional band or gain, rate, and the integral or the reset function. That means that to use Accutune, the process has to be running. It does no good to attempt to bench tune a controller with Accutune. Be my guest and try it, but I guarantee you'll be disappointed because your benchtop conditions do not mimic your process conditions. So the resulting tuning constants will not be correct. When you perform an auto-tune, the process should be as near normal operating conditions as you can get it. It makes no sense to Accutune a furnace with no load in the furnace because no one runs a furnace with no load in it. No load conditions are not the same as load conditions. So, when you do an Accutune, do it under normal operating conditions. In the next couple minutes, I'm going to show you how to do an Accutune on this Honeywell quartered-in UDC controller. Navigating through the menu and the keyboard on this UDC 2500 is the same or very similar to the UDC 3200, the UDC 3500, and the TrueLine circular chart recorder. Before we start an auto-tune, let's quickly go through how to read a UDC controller. The value on the top display up there is the process variable. It's what you're measuring with a sensor or a transmitter. It could be temperature, pressure, level, humidity, or flow. It's the current value of whatever's being controlled. The value on the bottom of the display, or the lower display, is the set point. Over here there's a lower display key. The lower display key cycles through 4 or 5 parameters in turn on the lower display. That's the second set point, 400. The output, OT, which ranges from 0 to 100%. 0% is fully off, 100% is fully on. DE means deviation, and that's the difference between the set point and the process variable. A deviation of 0 is good because it means they're both the same, which is what you want out of a controller. And then finally it comes back to the original one, cycles back to the set point number 1, which is 200. Over on the side over here, the capital F means F for Fahrenheit, degrees Fahrenheit, the temperature. The capital A stands for automatic mode as opposed to manual mode. And the capital L on the lower part of the display there means that we're looking at the local set point number 1, which in this case is 200. Now we'll tackle an auto-tune. The first task is to enable Accutune so that it can run. To enable Accutune, I press the setup key 3 times, 1, 2, 3, until it says A-tune or Accutune. And then I press the function key twice, past fuzzy, till it says tune on the lower display. DIS means disabled. Accutune is not enabled, it's disabled. I use the upper arrow key until it says tune. That enables auto-tune. The lower display key brings the controller back to operational conditions. Now when we cycle through the lower display, we'll see the second set point, the output, the deviation, and there's an additional setting called no tune. Accutune is an on-demand function. It does not run automatically, nor does it run on a periodic basis. Someone has to initiate the Accutune function in order to start it running. To initiate and run an Accutune, you change that setting from no tune to do slow. And you do that by using the up key until it says do slow, and you leave it there, and it will actually run the Accutune in the slow response mode. Once Accutune finishes, it'll actually come in, the process variable will come in and approach and stay at the set point if it's been tuned properly. The lower display key shows us that our set point is 200, and now after an Accutune, we now have 200 as our process variable. I'm going to use the set point select key to change to the second set point, 400, and we can watch the response of the controller as the process variable approaches 400. The reaction of the controller is vastly different than what it was when we started. We'll go back to 200 by touching the set point select key. You'll see that there's a little bit of undershoot, but it comes right back up, goes into 200. Be aware that I have special wiring here in Lessman's process laboratory to fake an Accutune, and to do so without being connected to an actual process. This setup is designed to do a rapid Accutune suitable for a short video. Do not expect your controller to do an Accutune as fast as this laboratory controller, because you'll be tuning on a real process, not on a fake process. Also, you should be aware that Accutune drives the output of the controller to 100% full on, then to 0% full off, back to 100% full on, and then to 0% full off in order to watch the response of the process. The implication of this is that your process can see or be exposed to 100% output or 0% output for some period of time. If your process or its contents can be damaged by not maintaining a tight window, then Accutune might not be the appropriate thing to use unless you can somehow simulate a dummy load. That concludes our demonstration of Accutune on a UDC 2500. Thank you for watching.